Welcome to the how-to for the wave nature of light. When we talk about light, light is one type of electromagnetic radiation. There are two main similarities between different types of electromagnetic radiation. The first is that all move through a vacuum at 3 times 10 to the 8th meters per second. This is known as the speed of light, and we recognize it with the abbreviation c. They also all have wave-like characteristics, which really means they have a wavelength and a frequency. So when we talk about wavelength, we usually use the symbol lambda to abbreviate for it. And we see that that's the distance between two adjacent peaks or troughs. So here we have one peak, here's the other peak, and the distance between that is equal to our wavelength. And we measure wavelength in meters. Frequency, on the other hand, is the number of cycles that pass a given point each second. And frequency is abbreviated with the Greek letter mu. And in this case, we're looking at how many cycles per second. And so the units for this is either cycles per second, it could be hertz, it could be per second, it could also be per second written this way. And so really there's a relationship between wavelength and frequency, which says that wavelength times frequency is equal to c, which is the speed of light. And so really when we look at this equation, and we say, okay, what does this really mean? Well, it means that 3.0 times 10 to the 8 meters per second is going to be equal to the wavelength times the frequency. So if we know the wavelength or we know the frequency, then we can substitute in and solve for whatever's left. So understanding that wavelength and frequency actually are related to one another, we can think about the different types of electromagnetic radiation. And in this, if we were to think about how the wavelength changes, whereas wavelength is decreasing, the frequency thus is going to be increasing. So wavelength decreases from right to left, it's getting smaller, whereas the frequency is getting much, much larger. And if we really think about what this would look like in a wave, we could think of two different waves. One, which is very spread out. And really, when we think about another wave, we could think about something that's much closer together. So, when we look at the wavelength, the distance between two peaks or troughs, we see that this is the wavelength. Down here, we see that value is much smaller. The distance between those two waves is much smaller. But when we think about the frequency, how many cycles per second, we can see that if we think about this as 1 second, there's not that many cycles. Whereas here, that same distance is going to give us much more cycles. So the smaller the wavelength, the greater the frequency, the more cycles per second. So we can see that as the frequency increases, you're going to get to higher and higher levels of electromagnetic radiation. That's why gamma rays and X-rays and ultraviolet rays are worse for you than something like a radio frequency. This completes the wave nature of light.